All right, this is going to be 2.3. And we're going to do multiplying and dividing exponents. Multiplying and dividing exponents. Do you have something to write with? Okay. Multiplying and dividing exponents. If you don't have a pencil, there's one back there. Okay, I'm not super concerned with whether you know if this is called the product rule or the division rule, or I'm not really concerned about you knowing the names of the rules. I just want you to know how things work. So if we look at this, it says multiplying monomials. First of all, what is a monomial? Haven't had that term yet. Let's add that to our vocab list. Monomial. So this word right here, a monomial. Does anyone know what mono means? Mono is it's not a disease. It's a sickness, yes. What did you say? One, right? Mono means one. So when you have a monomial, this is a term that only has one term in it. That's what monomial means. It's one term. And if you look at each of the things here, this is one term. This is one term. Okay, so monomial means it's one term. It usually means that they're multiplied together. Okay, something's multiplied together. So if we look at these examples, to multiply x to the a times x to the b, what we do with our exponents is we add our exponents if they have the same base. Now, if you look at this example up here, x to the a and x to the b, both of those are x, right? And we talked about x is the base. So if x is the base, you're going to add your exponents together. So this would really look like this. X to the a plus b. Now, just write that down. We're going to do some examples and you're going to be okay. So on number 17, it says find each product, which means you're multiplying, and then express your final answer using exponents. So when we look at number 17, do they have, first of all, what is the base? 3. You guys see the base is 3 for each of these, right? And what is the exponent then? What's the first exponent? 3. Okay, and then what's the other exponent? 4. So we are going to add the 3 and the 4 together. But before we do that, we write down our base, which is 3. You are not multiplying 3 times 3. You're not getting 9. You're keeping the base the same. And 3 plus 4 is 7. What this really means, folks, we know that 3 to the third means 3 times 3 times 3, right? We know that 3 to the third means 3 times 3 times 3. And 3 to the fourth means what? 3 times 3 times 3 times 3. So how many 3's do I have together? 7. That's where this 7 comes from. We have 7 3's all lined up. Questions on 17? So if we look at number 18, what is the base here? The base is -4, okay? We're putting it in parentheses because it has a negative sign. So when your base has a negative sign, you're putting it in parentheses. And how many -4's do we have total?
10.
Alicia says 10. I hear a couple more echoes. 10. -4 to the 10th. Remember, that's how we say it. We say our base to the something power. All right. 19.
And that's the answer.
That's the answer. That's it. Terry, I'm not trying to trick you here. That's it.
It just seems easy.
It does seem too easy. Okay, number 19 is 8 to the
Fifth power.
5th power. 2 plus 3. Ooh, what about 20?
12 to the third power.
12 to the 4th.
Yep, I was thinking that too.
Interesting. So on number 20, Will? I didn't hear you.
12 to the 4th.
Why is it 12 to the 4th? I only have 12 to the 3rd there. Hang on.
There's a 1 above 12.
Okay. There is a 1 here with the first 12. If we don't see an exponent, it's always a 1. You can always write it in. So then this is 1 plus 3 makes 12 to the 4th power. It only needs to be in parentheses if there is a negative with the base. If there's no negative with the base, you don't need to have it in parentheses. That's a great question. Okay, let's look at it when we have variables. Remember, variables are letters, right? We talked about that. Variables are letters. So if we look at number 24, okay, number 24, Chelsea, what might you say the answer for 24 is? Y to the 12th power. Anybody agree with that?
Mm-hmm.
I would. What about 25? Zaria, you want to give a stab at 25? Why is it P to the 7th? I only have P to the 6th there. Is there low key a 1 or there actually is a 1? Perfect. There actually is a 1, right?
Where?
No, it's low key because I can't see it.
Ooh. Okay, I see where you went with that. There's a hidden 1 there with that first P, right? We don't see it, but we always know that it's there. If there wasn't a 1 there, then that P would not exist. There has to be a 1 there. So this is, what'd you say, Zaria? P to the 7th. I would agree with that. All right, let's take it up a notch. Let's look at 26. Now we have X's and Y's. That's okay. We're just going to deal with one of them at a time. So if we look at X's, I have a 1 here and a 1 here, right? Put your 1s in for your X's. So how many X's do you have total? You have 2 X's. So I have X squared. And then how many Y's do we have? This side of the room says 7. What about this side of the room? How many Y's do you have? Shannon, how many Y's do you have? 7. We write them right beside each other, smash them together. This is called a monomial because there's only one term. There's no addition or subtraction separating them. So this is called a monomial. Do you guys want to try 27?
Yeah.
Okay, try 27. Let's see if we come up with the same answer. I'll let you answer. Just a second. Devon, how many M's do you have?
7.
So we have M to the 7th. N to the what, Devon?
5th.
N to the 5th? You guys agree with that? Anyone have any questions on that? Seems pretty easy, right? Okay, try 28. Terry, how many X's do you have on 28? What'd you say? So it's going to be X to the 4th. Jose, how many Y's are there?
8.
Y to the 8th. Raise your hand if this is your answer. X to the 4th, Y to the 8th. Awesome. Any questions on these? Okay, let's add another layer. You guys, you're going to be just fine. So the next thing is what happens when we have a coefficient Remember, we've talked about coefficients. It's the number in front, right? That's what a coefficient is. It's the number in front. So when we are looking at our coefficients, okay, we're on page 10, ladies. We're going to multiply the coefficients first. And guys, here's the absolute great thing about these packets is that when you go to do your homework, you already have notes exactly like your homework. All right? So when you go to do your homework, don't say, I've never seen this before, because we're doing notes exactly like our homework. All right. So it says multiply the coefficients first and then simplify the variables with the product rule. So that seems kind of crazy, but let's do this first. Let's multiply our coefficients. So in 29, use your multiplication sheets if you need them. On number 29, I have 12 times 4. Kiesia? You got your time sheet. It's okay, use it. 48. Okay, so we know 48 is going to be our coefficient. And now we don't need to worry about these numbers. And now I just do what I have been doing. Alicia, how many m's do I have there?
9.
That would be multiplying. What's 3 plus 3? 6. 48 m to the 6th. So we multiply our coefficients, and then we add our variables. Again, we add our variables because we can see a base for each of them. We're on page 10. Okay, let's try number 30. How many m's are there? 3 plus 3 is what, sir? Nope. Have we multiplied any of the ones up above? Okay. So why would we change our rules? Okay. Okay, number 30. Negative 2 times a negative 4 is what, Dontre?
Positive 8.
Positive 8. Excellent. Okay, and then we can forget about these. Ashley, how many V's do I have?
11.
Perfect. 8V to the 11th. Okay, let's hop down to 32. 32, if you look at that first parentheses, there's no coefficient, is there? There's no coefficient there. Or is there?
Yes.
Mandy's saying it's a negative 1. Do you guys agree that there's a negative 1 there? Okay, and we can write a negative 1 in. You can write your negative 1 in. And so when you're multiplying coefficients, you're multiplying a negative 1 and a negative 2. What is negative 1 times negative 2? Positive 2. And then I don't have to worry about my numbers in front anymore, and I can just use my variables. Christina, how many x's do you have? 9. David, how many y's? Perfect. 2x to the 9th, y to the 7th. Questions? Mackenzie.
I'm so confused. Why did you take this for this, but this?
Because you're multiplying your coefficients. So your coefficients here are negative 2 and negative 1. It's just like what we did on 30, right? We multiplied negative 2 and 4. Right? We multiplied negative 2 and 4, so we multiplied negative 1 and negative 2. Okay. I'd like you to try number 33, please. And then check with your neighbor to see if you guys got the same thing. Number 33, please. And check with your neighbor. Mm-hmm.
If you put a 1 in front of the y, would you count that wrong?
No. But if you do that, it's still, the 2 times the 1 is still 2. So no matter what, it's still just 2. $33 and check with your neighbor, please. You can use either one of these as your neighbor. Okay, Shannon, what's the coefficient? Our coefficient is the 3 times 9. What's your coefficient? Oh, I didn't. I'm sorry, I didn't hear
got-
you. You got done.
yeah.
I called you with food in your mouth. Okay, 27. Okay. Candace, what's our D term say? D is D to the what? How many D's do you have? D to the 9th. Devon, how many E's?
11.
E to the 11th. Raise your hand if this is your answer. 27, D to the 9th, E to the 11th. Awesome job, guys. Okay. Now I'd like you to please turn to page 14. Hop over to 14. On page 14, this is the things that we're going to learn today. And the first one we talked about was the product rule. Okay, so we just talked about the product rule. Remember, if you can see a base, I would underline this. If you can see a base, then you're going to add your exponents. So we can see a base here, which means I do x to the a plus b. So I'm going to add my exponents here. That's all I want you to write on this page. We're adding our exponents. That's what this rule said. Okay, hop back over to dividing monomials. So that's going to be on page 11. We're still in the same lesson. All right, so when we are dividing monomials, we use what's called the quotient. Why do we use quotient? Does anyone know? What does quotient mean? Quotient means division, right? It's the answer to a division problem. So when we are dividing monomials, this is what it looks like. Let's go to number 1 first, and then we will redo the rule. So let's do, this says we have 4 eighths. So let's go ahead and write 4 eighths on top. How many eighths do you have on the bottom?
2.
So let's write 2 eighths on the bottom. And now we can cancel things out that we have that are alike. So I have one pair of eighths that I can cancel and another pair of eighths, which leaves me with how many eighths? 2. 2 eighths left on the top or left on the bottom? 2 eighths left on the top. What goes in the bottom then? Not 0. 1. But do you have to put a 1 on the bottom? No, you don't. So this answer is just 8 squared. How did we get 8 squared?
2 eighths left.
Okay, we have 2 eighths left, right? And if we have 2 eighths left, it is 8 times 8, but before that, 4 divided by 2 or 4 minus 2? Which one are we actually doing? Are we going to divide or are we going to subtract our exponents? Let's try number 2 and see what happens. If I have 8 12s and I can cross 3 of them out, how many are left? 5. So what did you actually do there? You subtracted your exponents. So if I were to draw out 12 eighths, nope, 8 12s is what I meant to say. You don't have to do this on your paper. 5, 6, 7, 8. 1, 2, 3. I have 5 12s remaining. So I subtracted this 8 minus 3. So when you have a division problem, you're really subtracting your exponents. So up here where it says x to the a over x to the b, you find your answer by doing x to the a minus b. And maybe right above this, you can say subtract the exponents. So on number 2, if I did 8 minus 3, what is that really? 12 to the 5th. And that's my final answer there. I subtracted 8 minus 3 to get 12 to the 5th. Okay? Now, number 3, does it matter that it's a negative 5? No, it doesn't. So I'm going to put my base there. I'm going to put negative 5. But am I missing something?
The invisible one.
The invisible 1, right? We know there's the invisible 1 here with our 5 and negative 5 in the denominator. So 7 minus 1 is 6. So I have negative 5 to the 6th. If I left my answer like this, would I get full credit?
No, you need parentheses.
Thank you, Don Trey. If you do this and you leave your answer like this, your calculator, in order of operations, says do 5 to the 6th first and then apply the negative sign, which is actually incorrect because we want negative 5 to the 6th power. So when your coefficient is negative, you have to have parentheses. You have to. All right. What about number 4? Yeah. Yes, on number 3? Yes. Ladies?
I put the parentheses up. I put it around the 6 also. Does it
Nope.
have to be?
The 6 has to go on the outside. Yep. On number 4, what is the problem with number 4? Is there a problem with number 4?
Yeah, the bigger exponent is on the bottom.
The bigger exponent's on the bottom. Okay. So let's do it. Let's do a smaller example. If you had x squared over x to the 3rd, it would look like this. You can still cancel these out. You still have 1 left, right? 3 minus 2 is still 1. But where is your 1 left at? So your answer on, if this was the example, would be 1 over x. Okay? So you're still using subtraction. So on number 4, 9 minus 8 is what? 1. But where is it left at? Is it left on the bottom or is it left on the top? It's left on the bottom because that's where we had more of to start with. Does that make sense? I had more 2's on the bottom to start with. So I have 1 left. We're still doing 9 minus 8. We're still doing that for our exponents. 9 minus 8 is 1. But it's left on the bottom. Now, do you have to put 2 to the 1st power or can you just put 2? Just 2, right? You don't have to put the 1. But what has to go on top? Not x. We don't have any x's in our problem. In order for you to have a denominator, you have to have a numerator, and you have to put a 1 there. Because everything is gone in the top, except for 1. That one was a little tricky.
Yeah, definitely.
For the majority of the time, you'll see bigger exponents in the top. All right, what about number 5? So we know that our base is negative 3. What do we have to remember about this base? April says put the parentheses. 4 minus 3 is 1. Do we have to put the 1 there? Do you have to put a 1 or do we sometimes, as one of our classmates said, low key, we know it's there but we don't have to put it. Right? So if you put a 1 there, it's not going to be marked wrong, but you don't have to put it. Because if there's a negative 3 here, we know that there has to be a 1 there. Okay, try number 6, please.
But we didn't finish.
Okay. Jessica, what's your base on number 6?
10.
Okay. And what's your exponent?
9.
To the 9th. 10 to the 9th power. Any questions on 6? Okay, let's do number 7. Now we have a variable. Okay, do our rules change now that I have a variable? No, rules don't change when you have a variable. Haley, x to the what on number 7?
7.
X to the 7th. Anyone agree with that? Only half the class agrees with x to the 7th? Okay. All right, do we need to keep doing these, or you guys got the hang of it? We're good? Are there some harder ones at the bottom? Okay, so let's skip down to 13. So when we have a coefficient, we're going to divide our coefficients like normal. Okay, so just as you would in a division problem, because a fraction is a division problem, you're going to divide the coefficients first and then take care of your exponents. So if I look at this one, what is 6 divided by -2? Be really careful here. 6 divided by -2 is a -3.
And do we put parentheses around?
That's a great question. We'll talk about parentheses around that in just a second. Okay, you have R over R. So you have R1 over R1, right? What is 1 minus 1? 0. So actually in this problem, your R's completely disappear. Right? You had 1R over 1R, and 1 minus 1 is 0, so your R's completely cancel each other out. So you have no R's, and that's okay. Your answer is just -3. You don't have to have parentheses around this because there's no exponent. There is no exponent in this one except for 1. So we don't need to have parentheses here. Let's look at 14. 7 divided by 14. Can you take 7 and divide it by 14? Okay. Many of you in your head are doing 14 divided by 7, which is different than 7 divided by 14. If you have 7 over 14, you're really reducing a fraction. They both can divide by 7, right? Leaves you with 1 over 2. 7 over 14 reduces to 1/2. It does not reduce to 2. So this gives me 1/2. What happens to x to the 4th over x to the 4th? Keith, you want to take a stab at it? What happens to x to the 4th over x to the 4th?
It's just X.
Is it just x?
Or is it gone?
What do you think? It's one or the other. You're close. Think about number 13, when the exponents were the same. The r was just gone.
So it just goes away.
Yep, it just goes away because it's like this, guys. X, 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 X. Cancel, 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 cancel. There are no x's remaining anywhere. So the answer to 14 is just 1/2. Okay, let's try 15. What is 12 divided by 2? 6. Okay, so we settled that. We know that that's 6. And then what do we do with our exponents? Add, subtract, multiply. What do we do with our exponents? Subtract. 8 minus 2? 6. So I have n to the 6th. 6n to the 6th. Questions on that one? Okay, why don't you try number 16, please? Missing something here.
I actually do have a question on this 15.
What is 9 divided by -3? Good fix.
Okay, so like this one
Mhm.
is 7 divided by 14. You can do, isn't that the same?
No, because the bigger number's on the top. 12 divided by 2. I'm getting a crick in my arm. Okay, 9 divided by -3. Will, you want to take a stab at it? Excellent. Negative 3. Candace, what's my x going to be?
4.
X to the 4th. Okay. Now, do we need parentheses? This is a great question. So is the coefficient, is negative 3 being raised to a number, to an exponent? Does negative 3 have an exponent with it? No. That 4 is only going to the x, right? So in this case, since I don't have an exponent going to the negative 3, I do not have to put one around the negative 3. You only use parentheses around the number if the number is being raised to an exponent. This number is not being raised, this coefficient is not being raised to an exponent. Now, if you did put a parenthesis like this, it would not be counted incorrect. I would still give you credit for that, but you don't need to do it. All right. Okay, on page 14, we just did the quotient rule. So we've done the product rule, and now we just did the quotient rule. We have to do what with our exponents? Subtract them. Okay, so maybe also over here to the side, where I wrote these huge things, you can make yourself a note to subtract exponents, and maybe up here add exponents. Thanks. Okay. We're going to do our last one today, of our last exponent rule today, which is called the power rule. So when we go to the power rule, that's back on page 12. Okay. When we have a power rule, so I'm going to pause for just a second.